All right. Now, it doesn't matter whether or not you think a frequency is sharp, flat, or in tune. Those terms are relative. Now, using 36 tone equal temperament, you can reduce your perception to the fact of, okay, sharp, flat, and in tune, whether I'm tuning to 432, 440, or 448, is going to be objective in its wavelength. So after you reduce your perception to that fact, then you can expand your awareness to be able to recognize with your absolute pitch more than just what the note is called, where the note is in the range. So that you're able to recognize whether or not it's sharp, flat, or in tune, depending on whatever frequency you're given as your root. Now, if I'm going to tune to 424 hertz, 8 hertz lower than 432, the C will sound like a sharp B. Now, this C will sound the same as the B in 448 hertz. So I have my horn tuned sharp, and I'm going to play a B. Now, tuning flat and tuning sharp will be inconsistent. You want to find where your instrument is wanting to resonate the most purely in the center of the harmonic, okay? Now, so in 424, the C sounds like a B in 448. Now, if I'm going to put the C in 432, it sounds like a flat C in comparison to 440. So with all the tune slots pushed in, I'm either playing on the bottom of the harmonic for a C or the top of the harmonic for a B. If I go up another 8 hertz, go to 440, it's around in the middle of the range of each harmonic, okay? Now if I'm going to go up another 8 hertz to 448, it sounds like a C sharp in that 424 hertz tuning. So I'll either play on the upper part of the partial for the C or the lower part of the partial for the C sharp. So if there's going to be 3 different divisions for each of the 12 notes, 36 divisions, then you'll have 432, 440, and 448, and then 432, 440, and 448. If you choose to start on 448, it'll go 448, 432, 440, 448, 432, 440. If you choose to start on 440, it'll go 440, 448, 432, 440, 438, 448, 432. Are you seeing the pattern now? Now, those numbers are just objective, okay? Now, 448 hertz tuning sounds the same as 424 hertz tuning. It's just a different note that you're actually tuning to. 424 hertz in 448 hertz is an A flat. If you're going to call 448 hertz an A, then 424 hertz is an A flat. But those specific frequency ranges, those specific wavelength ranges, are objective in its comparison. So if you're going to tune to 440, play everything sharp and you'll be in tune, okay? If you're going to play sharp, you'll make the notes sound flat. And in tune is just stayed away from, okay? So let me give you an example of playing from the upper part of the partial to the bottom part of the partial. And then you'll hear how each harmonic is connected chromatically. Now, playing on the upper part of the partial and playing on the bottom part of the partial, that's a slippery way to play. So you have to figure out where the center of each harmonic is, and that's where it'll be most resonant. So if you have all your tune slots pushed in, then the middle will be around 440. So that's an octave of 440. Here, let me give you the sound so that you can hear it. La, la, la. You hear it? Now, 440 just so happens to be 40 octaves lower than the color yellow-orange. So if we're using RGB to give us a pure red, a pure green, and a pure blue, and a pure yellow, a pure cyan, and a pure magenta in 432, that's just where the numbers line up, then your concept of sharp actually shifts the color. Now, if everything is in between, you hear a lot of music around the range of 444 hertz. Now, 442 sympathetically resonates 444 because 444 is the quarter tone in 432. That's just how the numbers line up. Now, if you're hearing something like this, if you're hearing it sharp, which will make you miss notes, and you hear how it's in between, sounds in between A and B flat. Now, most people are going to play sharp. You're not going to hear, because 448 is a thing as A, and even though 448 comes from the 7th harmonic, which is an actual A sharp or B flat, you're either going to hear something, you're always going to hear something that's in between something else, okay? And when you do that, when you recognize that everything's in between something else, you listen downward, because everything's going to be sharp already, okay? You just have to know this. And then you label it as the lower pitch. If you hear it in between A and A sharp, just call it A. If you hear it in between B flat and B, just call it B flat. Okay? Does that make sense? All right, now I would like for people to start asking questions of things that I need to elaborate more on so that you all can understand exactly the objectiveness of this science. Thanks.